This is our experiment 5. The aim of the experiment is to use a given dataset to build SVM based classification model or support vector machine based classification model, and also to analyze the difference of outcomes by varying different support vector machine based classification parameters of SVM. So for this we are using the SONA dataset, and we are also using the SVM operator and making the connections, and we are running it. Here we can see the total number of support vectors are 208, and the weight of each attributes is given here. And when we are telling about this SVM are supervised learning models with associated learning algorithms that analyze data used for classification and regression analysis. A SVM model is the representation of the examples as points in space mapped so that the examples of the separate categories are divided by a clear gap that is wide as possible. So here some of the parameters of this SVM are given. One is the kernel type. The type of the kernel function is selected through this parameter. So here are dot, radial, polynomial. So here if I am taking the kernel type as radial and run, we can see the weight of each attribute has changed. Earlier it was 0 point something, but here now it is 50 to 45, like that. Then the another important parameter is the kernel cache. It specifies the size of the cache for kernel evaluation in MB. And the other more important parameter is the C value. It is an SVM complexity constant which sets the tolerance for misclassification, where the higher C values allow softer boundaries and lower value create harder boundaries. That means a low C makes the decision tree surface smooth, while a high C aims at classifying all training correctly by giving the model freedom to select more examples as samples as support vectors. So here if I am changing the value of to 5, we can see the value of this offset is being changed. Earlier it was 0.0 and we run it was 0.207, but if I change to 5, it has come to the offset is come to 1.156. So now we can check the accuracy of this SVM algorithm. For that we can use the cross validation operator. Now we can make the connections for this cross validation operator. And for this cross validation operator, there will be training subprocess and testing subprocess. The training we can give the SVM operator, and the testing subprocess we can give the apply model and performance operator, and we can give the connections. Now we can run it, and now we can see here the accuracy. What is accuracy? That is 78.86, and the class position is 77.894 rock and 79.65 for mine. Here if we change the SPM parameters like C equal to 5 and run it, here we can see the changes have come both in the accuracy and in the class precisions. So in this experiment we learn how to use this SPM and changes that occurred while we are changing the parameters of this SPM.